Nanotechnology, simply explained. What is nanotechnology? Nanotechnology is the science of manipulating matter at the atomic and molecular scale, dealing with structures between 1 to 100 nanometers in size. To put this in perspective, a human hair is about 80,000 nanometers wide. At this tiny scale, materials can exhibit unique properties, opening up a world of possibilities. The term nanotechnology was coined by Professor Norio Taniguchi in 1974, but the concept was first introduced by physicist Richard Feynman in his 1959 talk, "There's Plenty of Room at the Bottom." Feynman proposed the idea of manipulating individual atoms, laying the groundwork for what would become nanotechnology. Key components of nanotechnology. Nanotechnology relies on three main components. First, we have nanostructures, which are the building blocks, including nanoparticles, nanotubes, and nanofilms. Next, specialized tools like atomic force microscopes and scanning tunneling microscopes allow scientists to observe and manipulate matter at the nanoscale. Finally, the practical applications of nanotechnology span various fields, from medicine to electronics, showcasing its versatility and potential impact on our lives. How small is nano? To truly grasp the scale of nanotechnology, let's compare it to everyday objects. Imagine an apple shrinking down to the size of a nanometer. In that case, the original apple would be about the size of the Earth. If a marble were a nanometer, then 1 meter would be the size of the Earth. To put it another way, a sheet of paper is about 100,000 nanometers thick. This extreme smallness allows nanotechnology to interact with the fundamental building blocks of matter, leading to groundbreaking applications across various fields. Unique properties at the nanoscale. At the nanoscale, materials can behave differently than they do at larger scales. One fascinating property is the increased surface area of nanoparticles, making them much more reactive than their larger counterparts. Additionally, quantum effects become more prominent at this scale, affecting optical, electrical, and magnetic behaviors in ways we don't see in larger materials. Perhaps most intriguingly, some nanostructures can self-assemble, arranging themselves into ordered structures without external direction. These unique properties enable the creation of materials with enhanced strength, conductivity, and reactivity, among other characteristics, paving the way for revolutionary advancements in various industries. Nanotech in medicine, revolutionizing healthcare. Nanotechnology is transforming medicine in remarkable ways. Take drug delivery, for instance. Nanoparticles can now carry drugs directly to specific cells, increasing effectiveness and reducing side effects. This targeted approach is particularly promising in cancer treatment, where nanoparticles are being used to deliver chemotherapy drugs directly to cancer cells, sparing healthy tissue. In the field of diagnostics, nanosensors are making it possible to detect diseases at earlier stages than ever before. A team at MIT has developed nanoparticles that can detect cancer in urine samples, potentially revolutionizing cancer screening. Tissue engineering is another area where nanotechnology is making strides. Researchers have used nanofibers to create artificial corneas, offering hope to those with vision impairments. And in medical imaging, nanoparticles are enhancing techniques like MRI scans, making them up to 10 times more sensitive. These advancements are just the tip of the iceberg, paving the way for more personalized and effective medical treatments that could dramatically improve patient outcomes and quality of life. Nanotech and electronics. The electronics industry has been a major beneficiary of nanotechnology, driving the creation of smaller, more powerful devices. Modern transistors and computer chips are now approaching the size of just a few nanometers. For context, Intel's 10 nanometers chips contain transistors that are only 7 nanometers wide. That's about 10,000 times thinner than a human hair. Nanotechnology has also revolutionized memory storage. IBM has demonstrated the ability to store 1 bit of data on just 12 atoms, potentially leading to storage devices with unprecedented capacity. In display technology, quantum dots are improving color reproduction and energy efficiency. Samsung's QLED TVs use these nanoscale particles to produce over 1 billion colors, resulting in stunningly vivid images. Battery technology is another area seeing significant advancements. Researchers at Stanford have developed a nanostructured battery that can be fully charged in just 1 minute, potentially transforming how we use and charge our devices. Nanotech and energy. Nanotechnology is playing a crucial role in developing more efficient and sustainable energy solutions. In the realm of solar energy, nanostructured materials are pushing the boundaries of efficiency. Perovskite solar cells, which use nanocrystals, have achieved efficiencies over 25%, rivaling and potentially surpassing traditional silicon solar cells. Fuel cells are becoming more viable thanks to nanocatalysts. By using platinum nanoparticles, researchers have managed to reduce the cost of fuel cells by up to 80%, bringing this clean energy technology closer to widespread adoption. Energy storage is another area seeing significant advances. Graphene, a single layer of carbon atoms, is being used to create supercapacitors with almost instant charging times. This could lead to electric vehicles that charge as quickly as filling up a gas tank. Even waste heat is being put to use through nanostructured thermoelectric materials. NASA is using these materials to power deep space probes, converting heat directly into electricity. This technology could eventually be used to harvest waste heat from industrial processes or even your car's engine, significantly improving overall energy efficiency. Nanotech and materials science. Nanotechnology is revolutionizing materials science, creating substances with properties that seem almost magical. Carbon nanotubes, for instance, are cylindrical carbon molecules that are 100 times stronger than steel, but 6 times lighter. These are being used to create ultra-strong, lightweight materials for aerospace applications, potentially making space travel more economical and opening up new possibilities for exploration. In the world of consumer products, nanostructured coatings are creating surfaces with remarkable properties. The Nissan Leaf uses a nanopaint coating that repels dirt and water, keeping the car cleaner for longer and potentially reducing the need for car washes. The textile industry is also benefiting from nanotechnology. The US military is developing nanotechnology-enhanced uniforms that can detect and neutralize chemical agents, providing an additional layer of protection for soldiers in hazardous environments. Water purification is another area where nanomaterials are making a big impact. Researchers have developed graphene oxide membranes that can remove salt from seawater, potentially providing a solution to water scarcity in many parts of the world. Environmental applications of nanotechnology. Nanotechnology offers promising solutions to some of our most pressing environmental challenges. In the realm of water purification, nanomembranes and nanoparticles are proving to be game changers. A startup called Liquidity Nanotech has developed a water bottle with a nanofilter that can remove 99.9999% of bacteria and viruses, potentially providing safe drinking water in areas where it's scarce. Air pollution, a major problem in many urban areas, might also be tackled with nanotechnology. Titanium dioxide nanoparticles are being incorporated into self-cleaning building materials that can break down air pollutants, essentially turning buildings into giant air purifiers. Soil contamination, often a legacy of industrial activities, is another area where nanotech is showing promise. Iron nanoparticles are being used to break down industrial pollutants in groundwater, offering a more efficient and less disruptive method of soil remediation. In agriculture, nanomaterials are opening up new possibilities for sustainable farming. Researchers have developed nanoparticles that can deliver nutrients directly to plants, potentially reducing fertilizer use by up to 70%. This not only cuts costs for farmers, but also reduces the environmental impact of agricultural runoff. Challenges and risks in nanotechnology. Despite its immense potential, nanotechnology isn't without its challenges and risks. One of the primary concerns is the potential impact of the nanoparticles on human health and the environment. Some studies suggest that certain nanoparticles may be harmful if inhaled or ingested, and their long-term effects are not yet fully understood. This uncertainty underscores the need for continued research and careful regulation. The ethical implications of nanotechnology also warrant serious consideration. The ability to manipulate matter at the atomic scale raises questions about human enhancement and privacy. For instance, how do we ensure that nanotech-enhanced medical treatments don't create unfair advantages or exacerbate existing inequalities? And from a technical standpoint, scaling up nanotech production while maintaining precise control at the nanoscale remains a significant challenge. Many promising nanotech applications that work in the lab are difficult and costly to produce at a commercial scale. The future of nanotechnology. The potential future applications of nanotechnology are as vast as they are exciting. Imagine a world where products can be built atom by atom through molecular manufacturing. While still theoretical, this could lead to incredibly efficient and customizable production methods, potentially revolutionizing industries from electronics to medicine. In healthcare, the concept of nanorobotics is particularly promising. Researchers are working on nanorobots that could target and destroy cancer cells with unprecedented precision, potentially transforming cancer treatment. Nanotechnology could also enable more sophisticated brain-computer interfaces. Companies like Elon Musk's Neuralink are developing brain implants using nanotechnology, which could help treat neurological conditions and even enhance human cognitive abilities. In the realm of computing, nanotechnology is crucial for developing quantum computers. These machines, which operate at the quantum level, could solve complex problems far faster than traditional computers, potentially revolutionizing fields from cryptography to drug discovery. Even space exploration could be transformed by nanotechnology. NASA is exploring the use of carbon nanotubes to create a space elevator, which could dramatically reduce the cost of putting payloads into orbit.